gentlemen, welcome to this short video. We are going to solve problem 39 from chapter 10. With that, let's get started. In problem 39, we see that there is a truck that is storing energy in a flywheel. They give us the angular speed of 200 pi radians per second. One such flywheel is a solid uniform cylinder. So they're telling me the dimensions for the rotational inertia, gives me the mass and the radius. So I'm going to be able to solve for I, the rotational inertia of the flywheel. What's the truck's kinetic energy of the flywheel after charging is part A. And then part B talks about using average power, how many minutes can operate between chargings. So let's look at problem A first. In part A, they asked me to solve for the kinetic energy of this truck. We know that kinetic energy is equal to 1/2 mv squared. So the rotational kinetic energy is going to be 1/2 I omega squared, using the rotational analogy for mass and the rotational analogy for velocity. Since they told me that this flywheel is a solid cylinder, that's the same as our pulley. It's 1/2 mr squared for our rotational inertia. So I can go ahead and make that substitution. And when I solved that out, I got 4.9 times 10 to the 7th joules. So that's the amount of energy stored in the flywheel. The problem told me that the truck uses 8 kilowatts of power on average. So they asked me to find the time that the truck could run in between charging. Well, power is the time rate change of energy, work over time. So I can solve for the time, which is just the work divided by the power, or the energy divided by the power. They told me 8 kilowatts. So I'm going to write that as 8,000. And a watt is a joule per second. Watts power measured in? Exactly. Wow. Joules per second. So when I solve this out, I'm going to get an absolute boatload of seconds. Well, I don't want that because I'm going to convert it to minutes. And when I did that, I got 102.8 minutes. So there you have it. We saw how to find the energy stored in a rotating flywheel, as well as how to find the time that a truck could use that energy. That's all for this episode. We'll see you in the next one.